Hey everyone, Nick here. I'm going to redo this video because I had just learned OBS Studios and did not have the entire screen captured in my last video. So the bulk of the laser attachments, which is what I was talking about, didn't show up. So what I have here is a mock-up of my IKEA table and the MPCNC I put on it. The only thing I don't have showing is I use my own feet to make things nice and square. But I built the 23.5 millimeter version. This is all the burly parts. Even though I'm not using the burly parts, it seemed to work out fairly well. And these are the STLs that Ryan posts for the MPCNC. So all I did was import them as STL objects and gave them some pretty colors of something I'm going to do in the future because it kind of looks minionish, but nothing special. Just measured my tube and made an extrusion. And so what I have now is a scale version of the MPCNC, built the gantry and everything by making sure that the parts just touched and everything fit. So that's what I have. Makes it great for alignment, and I'm building parts that require knowing where your MPCNC is. So let's get started. Um, First thing I had to do was come up with where to put the laser. And if you look at my table, I built it edge to edge to edge with some room over here for putting all my electronics. So I really didn't have any room in the back. Typically, when you do a laser, the laser tube is oriented along the back side. It would hit the first mirror and come down to the second mirror, hit the third mirror, and go down to the work. Um, which is nice because then your laser, initial laser beam, isn't in line with you sitting here at the work area. I didn't have that room, so I did a modification and added a mirror zero. So what you see here is a mirror zero. And I mocked up the tube by measuring the outside diameter and just made a tube of it with a 3 millimeter beam coming out because that's what the specs call for. So this is a 3 millimeter tube textured in translucent red to emulate a laser beam, but it works for my purposes. So I have a mirror zero, and in reality, this mirror zero is a little more complicated than just a plain mirror. It does have a little LED diode that sits here and follows the beam. But for what I needed, um, when you set up a laser, where you put your tube isn't all that critical. It doesn't have to be at the same height as your moving mirrors. It doesn't have to be anywhere. It just has to be stable. You want to mount it so it doesn't move. And probably so you can get to it to change it and whatnot. And this mirror here isn't necessary either. As long as your laser can aim at the first mirror, mirror number one, it's the only static mirror that you'll have. That's all you need, because then that static mirror, his job is to be in a perfect alignment with mirror two. So by perfect alignment, I mean the mirror surface and the mirror surface should be at the same height, the same X, Y, left and right, so that this line that it winds up creating is perfectly perpendicular in all regards to this travel tube. And the way you can do that is what I did. I went ahead and put on my table, I screwed in a stick on both sides of the table that stood up in front of my mirror, and I sat there and I eyeballed them down this way so that the two sticks were perfectly over the travel of that mirror. And then I took a piece of twine at the top of the sticks and I pulled it taut so that it was just on top of this mirror, right over the center of the mirror, and creating a line right down the travel, so right above the mirrors. And with that taut, I would sit there and move the y-axis back and forth along its entire throw. So all the way up here, all the way down here, and make sure that the little scratch mark on the top of my mirror mount never moved. It followed that line. And after I got that figured out, I knew what path the beam had to take, and I knew exactly how tall my pedestal had to be to put this mirror right in line with this mirror, and from a center scratch, left or right where it had to be. And from there, getting this aligned with this mirror was a lot easier, a whole lot easier, because I'd taken all the physical fine tuning out of the picture, and it just came down to the little thumb screws on the back to make sure you get this laser parallel, perfectly parallel to this tube of travel. So then what you do next is you move this mirror all the way down here to the far end, and you get it set up so it's roughly in the middle. You know, you're not going to get it perfect, and it's probably not going to be the middle that you want it in. And you put a piece of tape over the mirror, and you draw a little X right where the laser hits. Now, I had a spotting laser, so I use that. But if you want to use the regular laser, then you just turn it on really quick and turn it off till it burns a dot. And then you move the laser all the way as close as you can get it, and you watch to see if that mark moved. This is where having the spotting laser really kicked butt, because I didn't have to keep changing the tape because I was burning holes in it. I could actually just watch the spotting laser. The only thing you have to do with the spotting laser is you have to dial in the thumb screws on the spotting laser so that it's following the current CO2 path. And once you get that fixed out of mirror 0, it'll follow the CO2 path from there forward. So you don't have to worry about where you move the other 3 mirrors. It'll always follow where the CO2 is going to go. And that made it really nice. So what I did is I could live move the gantry back and forth, and I could watch where it moved. And so if it starts to crawl up, then you know that your beam is actually aimed down at the mirror at a downward angle. And that's going to cause the beam to continue on a downward angle. So you want to correct that. You want it so that when it moves back and forth along this axis, there is no movement up or down or left or right. You need it to hold. It doesn't have to be in the center of the mirror. It could be down on this on the lower edge or off to the right, as long as you find the point where it doesn't move between full throws. Then you have parallel alignment with this post. And then you start from this mirror and you work towards this mirror. This mirror has a very nice flat surface, so it's a little easier to put a piece of tape across here and find out where the same point, by moving it from one side of the X to the other, the laser beam doesn't move. And when I wanted to make this mirror here, which is mirror 2, flush with mirror 3, that was the easy part, because doing it this way, I built the mounting arrangements with them already parallel. I mean, I drew them in Fusion perfectly parallel. The 2 discs spot on, because I mean I'm drawing them, so I can tell the collinear and whatnot restrictions that make them perfect. And then I built the mounts around them. So I already had the mirrors perfectly aligned. I designed this bed and these clips and whatnot. So you'll see that I bolt this part down, made a channel for this to fit into and whatnot. It's down this far for a reason, because I put this in place first and then built the table mount around it. And then I built if you look at, whoops, let me turn the table off. The table is just a tad intrusive if you want to look up. All right, so if I look up at my holder, this is my holder for my focus tube. I made this based on where this put me. So I mounted this, and then I figured out how to build the center point by drawing my tube in line with the downward reflection path of the mirror, and built this all around it. So that's what made everything fit right off the bat. Otherwise, I could have built in some kind of adjustments in this structure so that I could move it around, but I didn't. I made it fixed. You can't adjust it. And so these parts together work out. If you wind up changing tube diameter, you're going to have to take my parts, which I've given you the source files that are on the news or the Facebook group. You're going to have to do it all again yourself. And that's because I only have this kind of tube. I didn't need to make it for anything else. So that's why this right here is all perfectly aligned. Anyway, so yeah, then I had to sit there and go back and forth. And I think mine, if you look at where this is at, I mean it's dead center. Mine is actually kind of down here in the corner of the center in reality, and that's cool. What it does do is it does mean that when I focus my down my Z tube, if I can't get it perfectly in the center, it does mean that when I decide to change Z focus by more than about 10 millimeters in either direction, which I hardly ever do because I'm working with roughly the same thin material, I would have to refocus or re-aim this mirror to fit thicker material because if it's coming down the side of this tube and hits the lens, it won't project a fine point out the aperture of the nozzle. So I would have to align that, but I haven't had to align it since I started using the laser because while I made it so that my Z can move a lot, I find that I only move it about 6 millimeters in either direction, depending on the thickness of material I'm using. And that has yet to vary the focal point coming out of the nozzle. So been pretty fortunate there. One thing I will say is I always dual end stop the CNC before I start a cut series. One of the reasons is if this motor and let's back up a little bit. If this motor here and this motor here get a little skewed out of each other, they're not quite on step and step. When a job stops, it disengages the motors. If this were to skew a little bit, it changes the angle of this mirror, and suddenly I could have this beam hitting down here on the side of the aluminum or out on here in free space. And so just by zeroing it up each time, the motors engage, it goes to true where I've actually made all my measurements, and then I continue from there. So it's just one of those before you start safety practices. And I would imagine if you have a professional CNC laser machine, it probably homes itself before it starts any job anyway, for the same reason. If it has any way of becoming skewed, that could be a hazard. Anyway, so that's kind of what I did here. And I think next time I'm going to mount it under the table. I'm going to take the tube and put it under the table over here and probably have it shoot with the mirror zero up and hit this mirror and start things off because it'll conserve space and it'll keep my tube out of the way of things I'm working on. I almost dropped a wrench onto my glass tube and that would have really sucked. It would have destroyed my lasing ability until I could get a new one. So having this covered up just to protect the tube would be much better. Anyway, that's kind of what I did, and this is where it's of benefit. Like I said, this entire table, as built right now, the file is up on the V1 forum file section, and you're free to use it if it helps. You may have to design your own if you're using different size tube diameters, but it's not all that tough. Hope this helped kind of show you how the laser path worked and how I built and aligned the mirrors to make it a lot simpler on myself.